Hello, students. This is the next part of our surface chemistry. We have done up to our Schulze-Hardy law, and the rest of the part I will discuss today. So let us start the rest. See the rest of the surface chemistry. Okay. So again, in case of Hardy-Schulze law, we saw that higher the charge on the action ion, higher is the power of precipitation. This was seen by us in the Schulze-Hardy law. We have seen this before. So if you see that in case of aluminium 3 plus and magnesium 3 plus, sorry 2 plus, Al plus 3 has a higher precipitating power. Okay, this was seen by us in our Schulze-Hardy law. Okay, now what happens? We should see gold number. What is gold number? I'm just writing the definition first here. Gold number. Actually, the lyophobic colloids, lyophilic. The lyophilic colloids differ in their productive power. Protective power, and the power is discussed by our gold number. The gold number is, you can write down the number of milligrams. You can write down the number of milligrams, the number of milligrams of a lyophilic sol or colloid or sol that should be used to prevent, that should prevent the precipitation of 10 ml of a gold sol on addition of 10% sodium chloride solution. Okay, so this is the definition of our gold number. Actually, my English spelling may be wrong. There may be some mistakes. Okay, so I am sorry for that. So you should kindly correct those mistakes. Okay, so the number of milligrams of lyophilic sol that should be used to prevent the precipitation of 10 ml of a gold sol on addition of 1 ml 10% sodium chloride. I have not written here 1 ml. This is the gold number. This is the definition of our gold number. To understand it in a proper way, we can uh, solve a numerical problem. Then we can see how easy this one. Okay, let's see that uh, on addition of 1 ml solution of 10% sodium chloride to 10 ml of gold solution in the presence of in the presence of 0.0250 gram of starch was added. Okay, dust prevented. Starch was added to prevent the coagulation, to prevent the precipitation, to prevent the precipitation. Full stop. What is the gold number of starch? Okay, this is the numerical. So how to do it? What is the definition? The definition is how much. I have to find out what I have to find out. What I have to find out? I have to find out how many milligram of starch that prevented the precipitation when 1 ml 10% sodium chloride was added. Okay, okay, in 10 ml. This is exactly by the definition. So how many milligram? The starch is given in your gram. So milligram of starch is milligram of starch is 0.0250 multiplied by 1000, that is equal to 25 milligram. So the gold number, so the gold number of starch is 25. This is how the gold number must be calculated. Okay, this is actually very easy, and this comes in your CBSC exams also. So you should see this one also. So gold number is very important. Okay, this topic is known as your protection of colloids. Okay, protection of colloids. So there are also another type of expressions or or definitions which are also added. Okay, so it can also be used or the protective power can also be your calculated in presence of in the form of your Congo Rubin number. Okay, we have seen it in the gold number and another is Congo Rubin number. Actually, that is not in our syllabus, so I'm not going to the details of that one. Okay, thank you. Now we are seeing that colloids. What are the different types of colloids we see in our daily life? As an example, blue sky. It is also responsible. It is also the sky. The color of sky is blue. This is because the dust and the water molecules in the air uh, in the air distributes the blue light. Okay, actually the air, actually in presence of dust act as an aerosol. Okay, so aerosol, alcohol, it depends upon different cases, dispersion medium and dispersed phase. Dispersion medium, in case of dispersion medium is the air, and dispersed phase are the dust particles that are known as the aerosol. In case of aerosol, dispersion medium is the air, and dispersed phase is the dust particles. Okay, okay, dust particles. So such kind of classification of colloids can be done: aerosol, alcohol, hydrosol, etc. So you should Remember this one also. Okay, so the color of our sky is blue. That is due to the deflection or deflection of our blue light. Okay, due to the this is also like a Tyndall effect. Okay, you can see this. You can see that. Okay, Tyndall effect is our NCERT and also in our syllabus. I think we have discussed the Tyndall effect in the previous day. Okay, such as you can see that blood is also a colloid. Okay, okay, so you can see different types of colloids are there. Milk is also a colloid. Okay, so these are different types of colloids that are present in our surroundings and which are useful in our daily life. Okay, now we are going to a special type of colloid that is known as your emulsion. Okay, we'll see that what is emulsion. Oh, one very important thing we can see here. Uh, formation of delta. Formation of delta is also a very good example here. You can see river water contains differently charged species. Okay, river water, you can see that I'm writing here, river water contains different charged species. Now when river comes to the sea, as sea is a large source of different kinds of electrolytes, the precipitation occurs, and after a long time, due to the precipitation, the delta is formed. So this is very important actually, formation of delta. Okay, what happens? A river water contains differently charged colloidal particles actually. Okay, so seawater is a very big source of your electrolytes. What happens when, as soon as the river comes to the contact of the seawater, the coagulation or the sedimentation or takes place, suspended colloid particles get sedimented. Okay, suspended colloid particles get sedimented, and delta will be formed for a very after a very long time. Okay, so this is the process by which the formation of delta is done. Okay, when the river meets your sea. Okay, now we are seeing that what is emulsion. Emulsion actually what it is, a mixture of two non-miscible or immiscible liquids. Okay, two immiscible, I am extremely sorry if the spelling is wrong. I am not sure about the miscible structure. Miscible. Two immiscible. Okay, if it is wrong, you can correct it. Okay, two immiscible liquids when okay, a mixture of two immiscible liquids. Actually, what happens? You take a test tube here. Okay, this is a test tube. You take water here and give oil. This is water and this is well. What happens? Give the oil. This will not be mixed. Okay, oil is lighter than water, and the oil will occupy this position. It will form a layer. Now you go place this one in the centrifuge. Okay, what happens? You will see a mixture is formed, which is actually like this. You can see here. Okay, this type of this type of this type of phenomenon you will see. This is known as a colloid. Actually, emulsion. Actually, what happens whenever you give in the centrifuge, due to the rotation, the water, the oil droplets goes into the water and forms this kind of solution. This is known as an emulsion. Actually, emulsions are very important. Actually, emulsions can be classified into two types of emulsions are present. Actually, one is your oil in water type, oil in water. Another is water in oil type. Okay, oil in water, water in oil, two types of emulsions are formed. Okay, so I'm giving you some examples here. This one is milk, this one is your butter. Okay, and you can see cheese also, you can say, uh, or you can say also cold cream. Yes, that's a very good example, cold cream. And uh, you can milk in the oil in water, milk. And you can also say varnishing or vanishing cream, sorry, vanishing cream, etc. Okay, so these are the different types of uh, emulsions that are present. Okay, now we'll see uh, emulsifier and different types of emulsions. Okay, let's see. Emulsifier. Actually emulsifiers are used to protect the emulsion. Okay, or such as you can see that there is a classical example. Gelatin is used in ice creams. Okay, so why actually ice cream is a ice cream is an emulsion, either cream or foam in water to protect this. Gelatin is used as an emulsifier. Okay, emulsifier. Okay, so this is why gelatin is used in ice creams also. Now we are seeing an example of emulsification or emulsifier. You see, now let us take soap as an emulsifier. Emulsifier. Okay, what happens? Soaps are generally a large structure. Actually, that is this kind of a structure is formed actually. Okay, C15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, uh, C double O N A. Okay, C15. This is, I think, palmitate. Okay, you can also see 17H35 COONA. This is known as sodium stearate. Okay, sodium stearate a, actually a sodium stearate is actually a no biodegradable substance. Biodegradable. Okay, biodegradable substance. You can see here. So sodium stearate is actually biodegradable. Actually, these kind of salts the sodium salts of fatty acids are present in our soaps. What happens? What happens? It has two types of parts. One is this one is minus Na plus. This one is non-polar part. And this one is the polar part. What happens? What happens? Whenever a oil drop is present here, whenever a oil drop is present here, what happens? You can see the polar group goes like this one. Goes like this one. Now what happens? Now what happens? This kind of a cell type is formed. Okay. Now what happens? Now if you add water, what will form when water is added? Okay, due to the lyophilic interaction. Sorry. I'm trying to draw this here. Okay. Delta plus. Okay. H, O, H, delta plus, delta minus. Okay. What happens? This due to this kind of interaction, you can see that soap molecules gets concentrated on the surface of the oil drop, and wherever water is given, the interfacial tension. This term I was thinking about, interfacial tension decreases between oil and water, and the oil is washed away. Oil drop is washed away. So this is a very good example of emulsification. Actually, this will act as a very good emulsifier. So this kind of mechanism is very important. Actually, you can see the NCRT also. Okay. Now we have come to the end of this surface chemistry. Now we'll see some of the questions, okay, that were asked in the previous year question papers. Okay, let us see. Okay, at first the question in the book is, what is Hardy-Schulze law? Okay, so Hardy, Schulze. So I have written all the Schulze spelling wrong. Okay, so Hardy-Schulze law. What is Hardy-Schulze law? Very simple actually. You can say that higher is the valency of the ion, higher is the power of precipitation. Such as you can see that Al plus 3 has a more power than Mg2 plus. I have told you sometimes ago, to Na plus. Then this is for anions also. PO4 3 minus is greater than SO4 2 minus is greater than Cl minus. So this is the Schulze Hardy law. Okay. Next question is, what is Kraft temperature? So actually, a Kraft temperature is what? It is the minimum temperature above which micelles are formed. If the micelle spelling is wrong, you can correct it. Okay. MISCELLES. Micelles are formed. Okay. So this is the craft temperature. Okay. Thank you. Okay. Then one very important question is there. One is known as, what is peptization? Peptization. Sorry. Peptization. What is peptization? Actually, this is a very simple thing. Actually, the process of conversion, actually very simple. This comes our came in our previous year question papers, actually more than 5 or 6 times, or 8 not 9 times. Okay, so the process of conversion of a freshly prepared precipitate in a colloidal solution is known as peptization. Okay, so this was peptization. The next question is actually okay, fine. Gold number. Okay, gold number. Wait. Let us see another. Let us see another question of our gold number. You can write down at 50 ml of standard gold solution. 50 ml of standard gold solution needs 0.05 milligram of gelatin for the protection from coagulation. Calculate the gold number of gelatin. Actually, very easy. Generally, gold number is calculated for 10 ml of solution. Here it is given as 50 ml of solution. So we have to do what? We have to see 50 ml of gold solution requires 0.05 ml. Okay. So we can do in our unitary method. 50 ml of gold solution requires 0.05 milligram. Okay. 10 ml of gold solution require 0.05 divided by 50 multiplied by 10, that is equal to 0.01. So the gold number of gelatin is your 0.01. Next, what is the difference between colloidal solution and okay, fine. Lyophilic, sky appears blue in nature. We have seen that one also. Okay. Actually, another important numerical is here also. We can see this one also. You can see compare the coagulating power. Compare the coagulating power of HCl with that of KVR. Given coagulation values, given coagulation values are 30.8 and 138 respectively. So what we have to do actually, the coagulation power is inversely proportional to the coagulation value. Okay, what happens? The coagulation power is inversely proportional to the coagulation value. So we can write down at coagulation power of HCl. So we can write writing into the red in coagulation power of HCl divided by coagulation power of KBr is equal to coagulation value of KBr divided by coagulation value of your HCl. So this one will be 138 divided by 30.8, that is equals to 4.48. So compare the coagulating power. This is the answer. Okay. Next, we have seen what is critical missile concentration. We have seen this one also. What type of lipophilic and lipophobic sol emulsification, gold number. We have done it. Aqueous sols, colloidal solutions. Okay, aerosols. Okay, fine. So electrodialysis, we have seen this one also. Okay, okay, okay. Now, so this is the end of our surface chemistry. Actually, you should do the NCRT exercise. Okay, you can do the NCRT exercise, and I will also make a video on your. You should do the NCRT exercise. I will also make a video on the previous year NEET question papers. Okay, you should definitely follow your NCRT. No other book. This book is actually great. Okay, and this will give you a best idea of your um, syllabus and also your what is present in your syllabus, and the question does not come beyond NCRT. So you should definitely see your NCRT carefully and do the all the questions. Okay, gold number is most important. You can see the previous year questions, peptidization, okay, emulsification, gold number. These are the most important topics you should definitely cover. Okay, so I'm ending this video here. Thank you for watching.